So let's start with the today's presentation, and I will be giving you the webinar on electrohydraulic system. So before actually delving into the actual presentation, let me brief you about our corporate. Starting with the corporate presentation. So about us, Famic Technologies Incorporation. We do have 150 engineers and software specialists, and we are ISO certified company. And we were basically founded in the year of 1986. Our company organization's name is Famic Technologies Incorporation. We are leading the industry by designing world-class trade-oriented tools in the fields of fluid power, electrical engineering, industrial automation, and custom software development. So, as far as our offices are concerned, we do have our headquarters in Montreal, Canada, and then we do have two subsidiary branches, one being in Mannheim, Germany, and the second being in Pune, India. So as far as our in-house expertise is concerned, we do have three domains over here. The one domain is software specialists, the other is engineering domain, and the third is industrial automation segment. So as far as software specialist domain is concerned, we do provide software engineering tools. We do provide database and design support, network support, multimedia applications, object-oriented and web-based applications, and real-time systems as well. So when it comes to engineering domain, we do provide engineering support, pneumatic systems, hydraulic system, mathematical modeling, electrical systems, automation engineering, robotic system, and manifold systems. So as far as industrial automation department is concerned, we do have PLC programming, that is programmable logic controllers, then SCADA system, that is supervisory control and data acquisition, then HMI, human machine interface, electrical controls, process simulation, system maintenance, and last but not least, the robotics. So before moving ahead, here are some products which are flagship products of FAMIC Technologies Incorporation. First being Automation Studio Professional Edition. So this particular software is basically used by industrial experts and working professionals in order to create, analyze, and troubleshoot and validate multi-technology circuits. And when it comes to Automation Studio Educational Edition, which is our second product, so this particular software we do use to train future technicians and engineers on hydraulic, pneumatic, electrical, robotic, process control, and PLC system through simulation. And when it comes to Automation Studio Live Manifold, which is our third product, so this particular software is a complete hydraulic manifold software solution for designing, coating, and prototyping. And last but not least, we do have our software that is And-On Studio, which basically revolves around the concept of Industry 4.0, and it is a complete solution to optimize your production. So coming on to the objectives, we do believe in maintaining long-term relationship with our customer clients. We do provide effective support by phone, email, or online, and we have dedicated representatives for each account. And we do provide materials, support materials such as training videos, demonstration files, quick start guides, and so on. So today we'll be dealing with the Automation Studio Educational Edition. So before moving forward, here are some milestones achieved by FAMIC Technologies Incorporation. So as I briefed you, like in the year of 1986, we were established as FAMIC Technologies Incorporation. Then in the year of 1989, earlier we were known as Hydrosim and Neosim. Then in 1996, we labeled our software as Automation Studio, that is version 1.0. And progress was made down the line, taking into consideration the feedback from educational institutes, working professional, industrial experts, and we inculcated the improvement in the software. And recently, in the year of 2024, we have launched Automation Studio version 9.0, wherein we have included two new libraries, one being in instrumentation and process control, and the second being robotics library. So what basically is Automation Studio software? So Automation Studio software is a multi-technology and collaboration sharing multi-user software. So here we can see we have bifurcated the software in three segments. The one being simulation and animation, the second being trade-oriented system design, and the third being machine documentation. So as far as simulation and animation domain is concerned, we do have a hydraulic, then mechanical, electrical control, electrotechnical one line, digital electronics, instrumentation and process control, robotics, and PLC ladder logic. When it comes to trade-oriented system design, we do have diagram math, then CAN bus, that is control area network, and OPC, client service, that is open platform communication, then sequential flowchart, ladder logic, workflow, APIs, and failure maintenance. When it comes to documentation, we do have teachware module for students, then we have control panels and 2D 3D HMIs, then we have machine manufacturer's catalog, and the prominent feature of automation studio, that is catalog manager. I will brief you regarding this in the upcoming slides. And we do have bill of materials and reports. Yes, it is obviously supported in the automation studio software. The bill of materials, like you can get to know like what all components you are using, what is the unit size, what is the quantity you are using, what is the actual price of the component. All these many details will be tabulated in a tabular format, so which will be easier for customers and clients to understand. And you can also include the bill of materials in your reports as well. So basically you can create the reports using automation studio software. So we do have component sizing and energy consumption, then pneumatic module, then hydraulic manifold block, and last but not least, the hydraulic module as well. So this was regarding the basic framework of the Automation Studio, stating the capabilities of the software. On the right hand side, we can see orange box, which fits for multiple programs. So here we can see, as I mentioned, Automation Studio software is not a single technology, it is a multi-technology software. And it inculcates multiple segments, multiple domains under a single roof. So various fields such as mechatronics, industrial maintenance, aviation maintenance, that is aerospace engineering, then diesel agriculture and heavy duty mechanics, electrical, robotics and automation, instrumentation and control, renewable energy, then mechanical energy engineering technology, then HVAC, that is heating, ventilation and air conditioning, then marine technology, automotive. All these segments are covered in the Automation Studio software. Like you don't need to purchase different modules. You can base different technology. You can basically purchase Automation Studio and you will get these many benefits, these many domains covered. So what are the key benefits to students, teachers, and faculty and schools? So here we can see, when it comes to students, students can validate their theories studied in the class in much more interactive manner when it comes to Automation Studio software. And Automation Studio software has a probability that it can illustrate systems behavior dynamically in full color, which will be very much beneficial for student to understand the complex concept in a much more lucid manner. When it comes to teachers, teachers can facilitate the demonstration of the systems interaction in the Automation Studio software. Like faculties can explain a particular circuit from hydraulics, pneumatics, or electrotechnical, and so on, robotics, and it can enhance the teaching and learning by working on virtual systems as well. Yes, we do provide virtual system. We do have a prominent feature called digital twin in the Automation Studio software, which supports the domain of virtual systems. When it comes to school, so school can basically eliminate the need to purchase a single technology software. Like you don't need to purchase a software for mechanical engineering, for electrical engineering, for robotics. No, you can basically purchase Automation Studio software and it will cover all your domains. So that's why we stated Automation Studio as a multi-technology software. So yes, we do have a prominent feature in Automation Studio software, that is e-learning and remote access. So you can see, basically you can assign a student a particular task, a particular test, a particular experimentation work to student from a discrete location. Like he or she might not be able to attend the actual physical experimentation, but he or she can avail the same benefits by sitting at their discrete places. So here you can see they can enter full name, they can enter username, they can enter their email, and they can basically activate the test or experimentation and they can perform their activity. And faculties can also restrict the restrictions in a time bound manner, like he or she can finish off the particular task within a stipulated time. So this was regarding the e-learning. And when it comes to international presence, Automation Studio, we are available in the 13 languages in more than 150 countries. So here you can see a blueprint of the world map over here. So basically, Automation Studio software is used in high schools, career centers, colleges, universities, and workforce development. So when it comes to publication, you can see this is the particular Automation Studio user interface. Here we have created a, here we have basically dragged and dropped a pneumatic circuit. We have dragged and dropped this particular circuit from this publication, that is Fluid Power with Applications. So this is a publication written by Anthony Esposito, which covers around 300 to 400 hydraulic and pneumatic circuits. So the prominent feature of this publication is that you can actually drag and drop the particular circuitry onto your Automation Studio software, and student and faculties can get to know more about each and every component that is being used in the Automation Studio software in pneumatic circuitry. So this is a prominent feature for to understand a complex critical circuit in easy fashion. Not only this, but there are various other publications as well available. Like you can see electrohydraulic components and system, then fluid power engineering, and so on. So we do have interactive exercises domain in Automation Studio software, wherein you can see this particular hydraulic circuit. So you can basically assign student faculties can basically assign student a particular task by stating them this particular hydraulic circuit. Like faculties can ask questions to student like what is the load acting on this cylinder? What will be the piston diameter of this particular cylinder? What will be the rod diameter? What will be the stroke length? And so on. So it will be based upon mathematical calculations that needs to perform, and those calculations can be verified with the help of Automation Studio software by performing such interactive exercises. And you can also build in your own interactive exercises. You can easily customize these many parameters, and you can also create your own circuitry as well. So here you can see we have given options like MCQ options are available and descriptive options are available, and the flowchart can also be created with the help of Automation Studio software. So we do have digital twin of your own equipment available in the Automation Studio software, wherein you can see this is a virtual trainer kit. This is a hardware trainer kit for hydraulics. And on the back end, we have Automation Studio software. So basically, the communication between the Automation Studio software and the actual hardware is done with the help of OPC, that is Open Platform Communication Server Client. So what does this mean is basically if you try to shift the spool position of the DCV in the Automation Studio software, thus your cylinder will try to gain in the extended position. And once the cylinder is extended, it will be represented in the hardware trainer kit. Like in hardware also the cylinder will extend. So whatever changes you are doing in the Automation Studio software will be reflected in hardware over here. So this is what we state as virtual systems. So this is also very much possible in Automation Studio software. You can not only this, but you can also change properties or create faults for troubleshooting, and you can duplicate your hardware equipment virtually. So this was regarding the digital twin, and now we will talk about the illustrated libraries. So here we can see we have domains such as PLCs, AC/DC motor, pneumatics, and hydraulics. So these are basically 2D components which are readily available in the Automation Studio software. Like student will get to know like how actually PLC looks like, how actually multimeter clamps looks like in the real life, how electric motor looks like, what is the configuration of the DC, what is the configuration of the direction control valve, cylinders, pumps, FRL unit, and so on. So it will be very much beneficial for students to understand the actual components, how they look like. So here you can see we have three ways to create, simulate, and troubleshoot circuit. Like we have symbols, illustrated components, and virtual trainers. So here is one video for your reference. So we will be seeing some hardware connections being made over here on the left hand side on the actual pneumatic trainer kit. And on the right hand side, we will be seeing the pneumatic virtual trainer. That is, these connections are being made in the automation software itself. So there are same connections being made, same components being used, same cylinder, same DCVs. So this is how basically the Automation Studio software inlines with the hardware trainer kit. So moving forward. So what are the benefits of virtual plus hands-on experience? So here we can see on the left hand side we have hardware only and on the right hand side we have hardware plus Automation Studio software. So here we can see we do have three hardware kits available and only minimum number of students might be able to perform or perform these experimentation work over here, and it is a more expensive option. And on the right hand side we can see we have only two pneumatic trainer kits, hydraulic pneumatic trainer kits, and we have 20 user licenses. So more number of students might be able to take participate in the experimentational work. And as the hardware trainer kit required is less, so it is less expensive option. Like the capital investment required for a particular education institute will be much less as compared to the what we have on the hardware only side, that is three trainer kit. And not only that, but students can also work with the ISO symbol, that is ISO standard symbols, which are readily available in the Automation Studio software. Students can also change the properties of the components based upon their discretion, based upon their learning capacity. So moving forward, here we have available manufacturers catalog. So here we can see we have Argo Hythos, we have Bailey, Bimba, Booker Hydraulics, Camozy, Caspa, then Genetics, High Power, Poklane, then Vonberg, Viz, Vibo, and so on. UK Pump. So these many catalogs are readily available in the Automation Studio software. Now, what do I mean by manufacturer's catalog is manufacturer's catalog are nothing but ready to simulate pre-configured components which are available in the Automation Studio software. Say for an example, you are interested in Parker cylinder. So what you will do is you will go in the catalog, you will select Parker. In Parker also you will select cylinder, and you can basically drag and drop the cylinder in your actual Automation Studio software. So by doing this, students and faculties might get to know like how a particular industry models or takes into consideration the technical specification of each and every component. They will get to know like how industry actually functions when it comes to the hydraulics and pneumatics components. So not only that, but what will be the displacement over here? You can see like the technical parameters are have been mentioned over here. What will be the displacement? What will be the moment of inertia? What shall be the maximum pressure and maximum angular speed, maximum temperature, weight of the component that should be taken into consideration while modeling. So this is what we actually mean by manufacturer's catalog. So here we have taken the Parker cylinder. We have these many available manufacturer's catalog. And here we can see we have Bosch Rexroth pilot operated DCVs, direction control valves. So there are n number of components available. So student can take benefit of this and they can increase their knowledge learning capacity. So here is the partial list of our industrial clients from aerospace, agriculture, energy, forest, construction, defense, metallurgy, mining, then offshore transport system integrators and handling. So companies like Airbus, Boeing, NASA, CNHI, John Deere, ACCO, then ABB, Orano, John Deere, Kubota, then Caterpillar, Hitachi, Larsen and Toubro, JCB Defense, China Steel, US Steel, Epiroc, Komatsu, then BRMS, then Denso, Honda, RV Hightech, Hydraulico, Vomac, Skyjack, Terex. So these many are our partial list of industrial clients. There are many more. So this was regarding the corporate presentation. If you have any questions, please feel free to post your questions in the chat box. Now we will be starting with the actual presentation, that is the electrohydraulics. So I hope my screen is visible. So here is the user interface of the software, Automation Studio. So here we can see there are n number of tabs available over here above. Home tab, edit tab, view, simulation, system analysis, tools, student tab, support tab, and technical training material. And over here on the right hand side, we have Project Explorer, wherein you can basically click on this, a new project, and this will be the welcome screen of the Automation Studio software, wherein templates will be given for the user to choose. Like we have electrical, PLC, robotics, hydraulics, pneumatics, SFC graph set, instrumentation and process control, virtual system. Then we do have multi technologies, one line electrical, and so on. So for now, I will choose default as my template. Once you choose the template, This particular workspace area will be highlighted over here. That is the white spaced area wherein you will create your own circuitry work. I will choose the generic components over here. So here you can see under the library explorer, there will be n number of libraries available like hydraulic, proportional hydraulic, pneumatic, proportional pneumatic, drive and transmission, environment and control, instrumentation process control, electrical control, JIC and IC standard. We will make use of this as well in order to create the electro-hydraulic circuit. Then we have digital electronics, ladder diagram for Allen Bradley, Siemens, LS Electric, Mitsubishi, IC and NEMA standard for electrotechnical, then blocks, HMI and control panel, robotics. So these two new libraries we have added, instrumentation and process control and robotics. So as of now, we will focus upon the hydraulic segment, electro-hydraulic. So you can see if I click on the hydraulic, there is a small window pane over here wherein we can see the components that are readily available. So if I try to expand this library, here you can see there are more number of components available as soon as you expand the library. If you go in pumps and intensifier, you have these many options for pumps like unidirectional pump, unidirectional variable displacement pump, pressure compensated pump, load sense pump, amplifier, bidirectional fixed displacement and so on. And same goes for flow lines and connection. You have these many components readily available. Then accumulators also, gas accumulators. Then actuators, you have single acting cylinder, double acting, telescopic cylinder, brakes, mechanically linked cylinders and so on. So I will simply click on the hydraulic. I will try to create a circuit. I will simply drag and drop the components outside. I will be requiring. So it is this easy for you to drag and drop the components directly onto your AS workspace area. So once done, I will be requiring one direction control valve as well, which should be electrically controlled. So I will take this particular valve, direction control valve. Then I will be requiring one cylinder as well, double acting cylinder. Then I will be requiring pressure relief valve. So here you can see you have these many options available. If I go on to the pressure relief valve, I will drag and drop the component. Now I want to reverse the direction of this particular component. So what you can do is you can right click on this. You can go in the transformation, flip it vertically. You can see the direction has been reversed. Now we are done with the arrangement of the components. Now we will try to build a circuit, make connections. So the point to be noted over here is that the lines that I'm joining are not just CAD lines. These are actual pipes and hoses. So you can also copy a particular component and place that component by pressing the control button. So it is this easy to copy the components. Once done, I will link this as well, pressure relief valve, and you can see our connections are have been done, but we are left with one segment over here, one component. We can see red square. So this signifies that we have missed one connection. So I will be requiring one drive as it is a pump with drive mechanism. So I will be requiring some mechanical energy. So I have attached electric motor over here. So we are done with the connections now. Now we will try to simulate the circuit. So you can see the circuit is working fine. The pump is passing the flow to the circuit, but as it is in stop position, the DCV, it will not move the cylinder. As soon as I shift the spool position, you can see the cylinder is moving. It is extending. It is in extending position now. And if I try to shift the spool position right hand side, it will try to retract the circuit. It will try to retract its position, the cylinder. So this is how basically a hydraulic circuit works. Not only that, but if I try to double click on this, if you want the various technical parameters to be known, so you can simply double click on the hydraulic cylinder you will get to know these many technical specifications regarding the same. So here you can see we have damping coefficient, we have extension, inclination, what will be the angle of the inclination of the cylinder, what will be the piston thickness, viscosity compensation, and so on. Piston diameter, rod diameter, stroke length, and so on. External load, extension resistive force, retraction resistive force. So these many parameters you will be able to know once you double click on that particular component. Same goes for variable, pressure relief valve, pump. So these many technical specifications are there. You have also given the mathematical formula that is being used over here with the symbol. So this was it. I would like to present you one more scenario, like what if we attach the cylinder in parallel circuitry. I will double click on this, and as I stated you, like you need to mention the inclination angle over here. I will say for an example take 45 degree, but you can see even after I have entered the value 45 degree, it is not inclined at 45 degree. So you can basically go in the edit tab, coordinates and orientation. Over here I will select a particular cylinder that I want to give 45 degree. Over here I will type 45 degree. You can see it is successfully inclined 45 degree. Now I want to increase the load on this particular cylinder. So what I can do is I will increase the external load acting on this. Say for an example 1000 kgs. I will tick this in order to display the value. So you can see it is displaying me the value. And now I will try to simulate the circuit. Go in the simulation tab, press normal simulation. So you can see first this particular cylinder will try to extend, and after that only this particular cylinder will extend. And if I try to retract the circuit, first this particular cylinder will try to retract, and then this particular cylinder will retract, because we have taken into consideration the gravitational pull as well. So you can see this particular cylinder is retracting, and then once done this cylinder will try to retract. So this was regarding the circuitry work. Now what if you might be having question like if you want to measure certain properties, certain parameters. So what regarding that? So you can basically go in the measuring part over here, measuring segment. Under simulation tab, you can basically choose a, you will be having these many options available, like component dynamic measuring instrument, then node dynamic measuring instrument, differential dynamic measuring instrument. So you can choose these many options in the Automation Studio software. Once done, I am interested in the linear position. It should be in meters, and its value should be, precision value should be 0.001. So once done, I have completed the measuring instrument part. I want to know what actual flow is being transmitted through this particular hydraulic line. I will mark it, and I also want to know like what is the input pressure at this particular node that we have supplied to DCV. So once done, I would also be requiring to measure what is the piston side pressure at this particular cylinder. So once done, I will try to simulate the circuit now. So you can see there will be changes in the liquid, there will be changes in the properties over here. So you can see 37.48 liters per minute is being transmitted through this particular hydrostatic line, and it is somewhat around 80.09 bar of pressure being generated at the output side of the piston. So this is how you can take into consideration the various measuring properties and perform the measuring operation. So once done, we have completed this particular segment, measuring instrument. Now I want to focus you on what if you want to measure certain property across this particular DCV, that is pressure difference. So you can make use of differential pressure measuring instrument. in bars 0.001. Yes. So you can see that is P1 minus P2. You are getting somewhat around 79.68. So if I try to shift the spool position, you will get 0.48 bars. That is the pressure difference across this particular 4 by 3 DCV. So this is how you can take into consideration various measuring properties and measure certain properties. Now we are done with the measuring part. Now we will see like how YT plotter, that is if you want to represent your mathematical calculations in a graphical format, so you can take into consideration the YT plotter. So it will basically plot. So you can basically drag and drop a particular component that you need to measure. Say for an example, I need to measure linear position or linear speed of the cylinder, and I need to measure the input flow and input pressure. So once done, I will try to simulate the circuit now. So you can see it is plotting the graph. If I try to auto scale this, you can see the graph has been plotted and it is representing in such manner. You can also enable the legends, like yellow represents the linear speed, the blue represents the input pressure. You can also add multiple cursors in order to get to know the exact value at a particular instantaneous amount of time. Not only this, but you can also copy the plotter image. You can paste it over here for easier understanding of the faculties and students, like how basically a particular system is working. So this was regarding the YT plotter. We have YX and XYZ plotters as well for 3D and 2D respectively. So for now, we are done with the measuring instruments. We are done with the YT plotters. And now I will delete some measured instruments, and we will focus upon now connecting the hydraulic segment to electrical part, how you can do so. So for that, I need to close this hydraulic library and I need to open electric control library, that is IEC standard. So you can drag and drop. I will be making some connections, electrical connections. I will be labeling it as push button 1 and this as push button 2. Once done, I will be requiring solenoids as well. Solenoid 2. Now I will make some connections over here. So the lines that you are seeing are not just CAD lines, they are actually electric wires. So we have successfully made a electrical circuit. Now we are left with the connections. So if I go on to the direction control valve, which is solenoid operated, so you can go in the variable assignment tab and type over here as solenoid 1. I will link this. I will link solenoid 2, the right solenoid. Yes. So we are done with the electrical connections, as well as we have linked the electric connection to the mm, hydraulic circuit. Now we'll try to simulate the circuit. So you can see if I press the push button 1, my solenoid 1 will get energized and it will shift the spool position of the DCV. So you can see it has successfully shifted the spool position of the DCV and the circuit is working fine. So we are not touching the hydraulic part over here. We are just giving some electrical pulses with the help of electric circuit and it is being transmitted to the hydraulic circuit. So you can see this in this manner you can basically operate your hydraulic circuit with the help of electric circuit. So this was the case for electric circuit and hydraulic circuit. Now we will see one part, that is troubleshooting. So in that, if I try to simulate the circuit, you can see now if I try to extend the cylinder, it is extending by changing the spool position of the DCV. But what if there might be condition like your cylinder might not extend even after you shift the spool position of the DCV? How come it is possible? I will show you that. Simply, I will creating a troubleshooting scenario over here by locking the cylinder. I will activate the failure over here. Once done, I will activate the failure. You can see the cylinder has been locked. Now, no matter how hard you try, you won't be able to actuate the cylinder. You can see this particular cylinder is extending, but this particular cylinder is not extending, even though the supply is being given. So why it is not extending? Because we have jammed the piston by creating a troubleshooting scenario. So how you can check that particular thing, like you can use the hydraulic tester over here. So I will take one probe, I will connect it over here. I will take the another probe, I will connect it over here. So you can see it is giving me 50 liters per minute of flow. See, you can see student can basically see 50 liters per minute. Over here also it is 50 liters per minute. But once you drag the probe over here, you can see 0 liters of liters per minute flow is there. So in this scenario, we can get to know that there is something wrong with the cylinder. So in such scenario, what you can do is you can basically click on the repair tool. If you click on this particular cylinder, select all failures, press tick button. So now you can see the cylinder is moving. So this is how you have troubleshooted successfully your circuit. Like now it is working fine. Okay. So with that being said, we have looked upon hydraulic circuit. We have looked how to create electric circuit, how to link electric circuit with the hydraulic circuit. We have seen YT plotters, we have seen measuring instruments, and now we'll focus upon the PLCs, like how you can link your hydraulic circuit to the PLC. So for that, you need to basically again go in the electrical library, electrical control library. Here you will be having PLC cards. So you can basically drag and drop the PLC input card and output card respectively. Once done, we will be requiring some electrical connections to be made over here. So we will take 0 volts over here. Then we will take 24 volts of supply line, and same goes for in downward fashion over here. Okay, once done, I will mark some connections. We will be requiring solenoids again. So I will take solenoid, I will label it as extend, and I will drag and drop one another solenoid. I will label it as retract. Once done, I will make some connections over here. And then I will take push buttons. I will label it as button 1. I will label it as button 2. Once done, I will make some connections over here as well. I will shift it in upward direction. Yes, we have made the connection successfully. And now it's time for us to bring the ladder. So I'm going in the ladder diagram for Siemens. So here you can see we are running short of space. So what you can do is you can just go on the home tab. Click over your document, ANSI, choose B or C depending upon your sheet size, adjusting it a bit. So now making connections, that is placing normally open, normally close, giving it output coil over here. Again using as a latch mechanism over here, giving output coil over here as well. We have normally open, we have normally closed. Again we will latch it. We will be using it as memory coil, making connections. So now our ladder logic is ready. We just need to assign the addresses. So double clicking on this, you can basically double click and go in the variable assignment tab. I will minimize it. So instead of assigning, I will assign it as IN1 as it is in IN1 position. Once done, I will assign it as IN4. Yes, we have done. And then output, I will, as our solenoid is in output 0, so I will give over here it as output 0. Over here as well, we will give it as output 0. And here we will label it as IN4. Same goes for this. We will label it as IN1. Here I will give it as output 3. Here also I will give it as output 3. So we have made connections, but still we are left with one more thing, that is the DCVs to be connected with EXT, extend, and over here retract. Okay, it has not yet linked. So again need to go in the solenoid, delete the earlier connections made, and then now connecting it to the retract. It has linked, and connecting this to extend. So in this manner we have linked the circuitry, hydraulic circuit. Now we'll have to simulate the circuit. So in simulation, we don't need hydraulic tester now. I will retract first of all this circuitry. Yes. So now if I press the button 1, you can see our ladder logic is working fine. With the help of the ladder logic, it is implementing the hydraulic circuit. The cylinders are getting in extended position. And if I press the push button 2, the cylinders will retract. So this is how basically your electrohydraulic circuit works with the help of PLC playing an intermediary role. So we have so far looked electric connections, like using basic electric circuitry, how hydraulic system works, and we have also used PLCs as well. So now we do have one external feature, that is hydraulic sectional components also available. So here you can see, if I try to open the hydraulic sectional components over here, library, we have pumps, we have tanks, fittings, accumulators and actuators, cylinders, motors, direction control valve, we have on off and proportional, then flow control valve. So this is an extraordinary feature that we do have in Automation Studio software for easier understanding of students and faculties. So now I will quickly draw a circuit with the help of these sectional components. I will take a tank over here. Once done, I will be requiring fitting, T type of fitting. I will be requiring direction control valve, which should be solenoid operated. So we do have 4 by 3 solenoid operated DCV. And then I will be requiring cylinders, that is double acting cylinder. I will choose this cylinder. Yes. So now I will go in the view tab. I will open the connection port name. So here you can see we have port names also visible over here: A port, B port, tank, B port, P port, A port, and so on. So I will try to make connections now. We will be requiring one pressure relief valve as well. So going in the pressure control, relief valve, we do have over here relief valve available. So now quickly making the connections. We will try to connect the S port over here. We will be requiring P port over here, then giving it to A port, connecting B port, giving it to the pressure relief valve over here, connecting to P port. Okay, so we have done the connections, and now we need to again link this particular DCV to the electric circuitry. So what we can do is we can simply go in the variable assignment tab. To the left solenoid, we will be connecting the, as we want to operate this particular sectional circuit with the help of PLC. So I will try to connect it with the EXT, that is transmitter, and the right hand side of the solenoid to the RET, transmitter again. So once done, I will try to simulate the circuit now. So here you can see if I try to push it, so it is operating. Okay, if I try to retract it, the cylinders are working fine. So this is basically how a sectional component actually works with the help of the PLCs, and both the hydraulic circuit and the sectional components are working with the help of the PLCs, that is programmable logic controllers. So this was regarding the hydraulic sectional components as well. So now we will focus upon the pressure sequence valve. So for that, I will basically draw a hydraulic circuit for pressure sequence valve. I will take one hydrostatic reservoir over here. I will take unidirectional pump with drive mechanism. I will be using one sequence valve. So here you can see we have sequence valve. I will take it. I need to reverse its direction. So I will simply press Ctrl R to reverse the direction of the sequence valve. And then I will be using DCVs going in the hydraulic direction control valves. We do require 4 by 3. So I will place it over here, 4 by 3 DCV. I want to copy this particular DCV over here as well. So I will simply press Control button on the keyboard and try to paste the DCV. I will be requiring one cylinder as well, 2 cylinders. So going in the actuators, double acting cylinders, reversing its direction. Again, copying the same cylinder over here as well. So once done, we will be requiring one drive in order to drive the pump, as it is a drive mechanism. So going in the drive, electric motor. I will be requiring one pressure relief valve as well. Pressure reducing valve, which is pilot operated. Okay, so now making the connections. So what we can do over here is we can simply make connections over here, giving it to the P port over here, supplying the pressure to the cylinders, then directing the flow towards tank. So we'll be requiring external reservoir over here. Giving it the pilot to the tank. Once done, we will make connection in this manner. Again, we will be requiring additional tank over here. So making the connections. So in this manner, again, one separate tank is required over here as well. So in this manner, our circuit is ready. Now we will try to simulate the circuit. So if I try to simulate the circuit over here, so we can see there is one more feature that you can press left click on this line, and as it is a pilot line, so you can choose a pilot over here. Similarly, here we can see it is a pressure line. It's correct. Over here it is a drain, so we will choose drain function over here, drain line function, return line, and so on. So you can see these many options are available. Like you can choose whatever best desired function of a line capability over here. So it is, you can choose. So once done, we will try to simulate the circuit now. Okay, need to link this particular circuit to the electric as well. So what we can do is we can basically copy this particular circuitry from here. I will try to link this particular circuit to the electric circuitry. So we will be requiring two additional solenoids. Okay, double clicking on this, going in the solenoid 1, as we have labeled it as solenoid 1. So this solenoid 1 and this will be linking with solenoid 2. Okay, this should be linked with solenoid 1 and this particular solenoid should be linked with solenoid 2 over here. Once done, we will do the same for the next DCV. We will label it with solenoid 2 and this right one we will link it with 1 solenoid 1. So now we have done the connections. Now we will try to simulate the circuit. So if I press the push button 1, you can see the cylinder 2 is extending, but cylinder 1 is not extending. And if I press the push button 2, it is retracting. So now why this particular cylinder is not extending? Because the pressure of the sequence valve is very much high. So what you can do is you can simply click over here. You can reduce the cracking pressure of the sequence valve over here. Say for an example, I will label it as 53. Now if I try to simulate the circuit, so you can see the cylinder 2 is extending, and once it is done, I will label it as 60. It is retracting. If I try to extend, if I try to increase certain amount of pressure, try to retract. Okay, so need to increase certain amount of pressure over here. I will make it as 90. By this particular cylinder should extend. Okay, there is some connection issue over here. Going in the solenoid, it should be linked to solenoid 2 over here. Deleting the link, it should be solenoid 2. So now it is perfect. Solenoid 2, solenoid 1, yes. So now try to simulate the circuit, making it as 50. Now the cylinder 2 is extending, and once it is done, my cylinder 1 should also extend. So here you can see this is how a sequence circuit actually works. So here we can see the sequence valve functioning properly. If I try to retract, the cylinder 2 is retracting first and then cylinder 1 is retracting. So this is the basic functioning of the sequence valve. So yes, if you have any questions, please feel free to raise your questions in the questions tab. We would be happy to address all your queries. So far, let me just summarize you what we have seen so far. We have simply drawn a hydraulic circuit. We have seen measuring instruments in the simulation tab in measuring instruments. Then we have seen some YT plotters. Then we have linked the particular hydraulic circuit to the electric circuit. And then we have linked the hydraulic circuit to the PLCs. And then we took into consideration the sectional components as well, and we have linked the sectional components to the PLCs as well. Then we have seen like how a sequence valve actually functions by taking into consideration this particular hydraulic circuit and then linking this hydraulic circuit to the electric circuit as well. So this was the basic crux of the webinar and we have covered so far. And if you have any questions, please feel free to post your queries in the question tab.
Thank you, Rohan, for today's webinar. If you have any question, you can email us. We will address that queries. And please do register for your tomorrow's webinar, which is on electro-pneumatic. This is the series of webinars. Please do register for the next webinars for. And tomorrow we have a webinar on electro-pneumatic. So please do register on that. Thank you.